Good day, guys. We look at control flow statements in C++. We look also control iterations as well. We're going to look at what control flow is and the iterations. They are very, very important in all programming language, including C++ as well. Now let's dive in and let's see what control flow is. Control flow refers to the mechanism that dictates the order in which statement is executed in the program, in our code. It allows for dynamic, responsive, and intelligent logic. The importance is that without control flow, program will execute strictly sequential, just in our normal way. So now the control flow is essential for decision making, executing different code parts based on conditions, repetition and looping, repeating a block of code multiple times. You can loop it. So we need this just in our daily operation as well. We make some decisions. We make some we repeat some tasks severally in some sequence manner. We also see this also appear in our program as well. We also see branching, altering the execution of the path. We may decide after looping for a while, we may also want to branch to other situations. We also have branching. Also, let's see some categories. This category in C++. With this selection statement, choose one execution path from several possibilities using the keyword if or switch statement to be able to carry out these conditional controls on our codes. Also looking at the iteration statements, also enable us for repeated operations like for, why, do why. Also look at jump, the jump statement like break, continue, return, go to statement. The go to statement is discouraged by developers. It's not encouraged using go to statement. You can easily use break or continue or to jump out of executions. Also, let's see a sample of this. A sample of conditional control statement using of if statements. If an age of a user is greater than this, then you can easily carry out this code. If age of an adult is this, then you can make a vote. You can vote on your code. You can see if statement here. This if statement is a single conditional check. It's check for single conditional statements. Then you can also have the if else statement in case there's maybe you want to carry out some execution. In case the execution does not flow as we planned, then we can also still make else. Then this else statement, the else statement enables us to that you can see that provides an alternative executions. Now, if score is equal to 75, maybe the student score is 75. But the score we initially ask score greater than equal to 50. You should do this. Else, we should also fail. It fails, but the first condition will be executed. That means pass will be executed. But if the score will later change it to what? To something like maybe 27 or 45. But this elder condition will be executed. Now let's look at what the use of the chain multiple condition statements. The first two conditions check. Let's check if the grade of a student is equal to 70, 85 or greater than 85. This is a grade of a student. If the grade is greater than or equal to 90, then we should print out what? A. As if a grade is greater than or equal to 80, then we should print out B. That means here, this condition will be executed for this statement because our grade is 85. As if, we can have out of as if, but make sure before you can use this as if, there must be one if that started it. Understand? Before you can have as if we start it, as if we continue, as if we follow, then the final we have now have s. Just know once we have a chain in this multiple condition check, understand? We can what? The else. Okay, in case there is nothing else that matches, then execute the final one. Then we are efficient. Let's look at switch statement. It enables to efficiently select execution path from multiple statements. The value of the single integer type like int, char, enum, or enum expression. Let's see example. Let's see the syntactic example, the structural example. Let's see if char choice equal to what? B. Switch choice case A. Now, this is what is going to happen here. It's when this choice matches any of these keys, if like you are using if statements, if like now our own we have choice to be B now, that means it will come A down here, and option B selected, then it will execute the code. Mind you, also consider a break statement. If the break statement is not included, you still continue to execute everything the same way, it will not break out of the conditional check. So in that case, we have to know that we have to include the break statement at the end of each case. At the end of the case, full column, this that's overflow to this line, then we break. Right? Crucial exit the switch statement immediately once the condition is checked. If the condition is not found, if this thing is not found, then we just default, we just like X statement will happen. This default value here, sorry, but in our slide is good. I'm going to rectify the error in the slide. Then let's look at iteration loops. Loops. We have a sequence of, we have a series of items. We want to go through them one after the other. We have to loop over those items. That is the reason why we have loop statements. We have for loop. We make use of for loop in case we know the beginning of a thing and we know the end of that thing. Maybe we know that the total number of students should be here, should not be more than 50. We know, okay, now the total number of students in the class is maximum is 50 in an engineering class. Therefore, we look from 1 to 50. Therefore, let's look at how the syntax structure looks like. This is how loops look like. Then this is how it look like here. Just for int I equal to 0, less than 5. For example, as I was saying the other time, as I was saying, sorry. For example, if we have this, let me just look, for example, can just, okay, for maybe int I equal to 0, I less than, maybe equal to what, maybe 50, for example, less than equal to 50, I plus plus. In case you are wondering, these structures here that my own error is showing here, I just go to the market, search for error lanes, and install it, so the error will be displayed by your right hand side. So therefore, now we can also look for, we can now print out the code. We can print out the result. Let me correct this thing here. Because it's telling that NL is not found, but it's undefined. But instead of inputting STD all the time, I can easily add a namespace that will include all the STD. I can just use come here using namespace STD, or you can just say this is our scope operator STD. Use this as scope operator. You can also include it yes individually if you want. STD using the fork C out. Don't do them one after the other yourself. So it says the namespace that's STD C out. There must be a namespace. It said there's an STD. Yes, STD. And we leave it here. Can you see this? The error disappears. So you still work the same way, but just include it. You can also remove this one as well. So then we are good to go. It includes all the standard libraries without need to be putting STD in front of them anymore. Can you see now? We can easily print them out. We can put them out after the order. But if you put it down, you see it displays vertically downward. Can you see it will display vertically downward? Can you see 0, 1, 2, 3 up to 50? Can you see? It started from 0. We see this is the for loop. It's divided to 3 section. The for loop, the first one is what? The initialization. The second one is the what? The condition to check whether something, the condition to check. And the third one is what? The increment and the decrement. Understand? Then you can start from anywhere. You can start from one, so it will display. But we can also make it to what? To display horizontally. How do you make it to display horizontally? Just remove this end L from here. See out this. But you can either come here so that it won't combine, it will not join it with our, we have a free line, it won't join with our console data. Just come here and run it again. So here, maybe an error here. See out this 1 equal to 50, 1, 2, 3, 4, 5, 6. But how do we separate it? Let's separate it with comma, so that we'll be able to see, comma, separate this. Then you can also make use of tab, /t represent tabs. Then you can easily run it again. And see, we have the code this way. Now, this is our code now. Well separated, but with comma here. Now let me come back to our slide. Can you see now? It flips all this. Now let's repeat a block of code as long as specified conditions. Let's see while loop as well. In case we know the beginning of a thing, or want to check for a condition, let the loop start continues till let the loop continue until something just, in case there's something, I'll just terminate when something happens. We don't know the beginning, we don't know the end. But in case we have some condition to happen, let the loop terminate. We can use the while loop statement to achieve that. Maybe, okay, we want the user to enter, to keep on answering like a prompt, to keep on asking the user until the user enter the right password to the system. The system should keep on prompting, please enter the correct password. Please enter the correct password. We're going to look at that and check as well to demonstrate that as well in this code before we leave. Then let's look at the do while statement as well. The jump statement we used to terminate for a loop to break out of the statement. Okay, maybe for example, we want to display up to 10, but if I equal to 5, just break. We want to stop at 5, not even to complete the statement. It's going to terminate the flow of this of the execution. Then also see the return seriously continue statement. By the time instead of it breaking from that loop, it will just continue. It will jump. If I equal to 2, that means it should what? It should continue. Once by the time I equal to 2, it will skip 2. It will jump to 3 and print out 3, 4. Instead of it printing out 1, 2, 3, 4. It will skip that number. That's continue with jump exact statement. It will jump. We also have go to statement. Can you see it's strongly discouraged in modern C++? At least to what? To unstructured hard to read and maintain. You see, go to this, go to D. It's always create a what? Make it what? We make it a ball, even your code. Of course, it's true exception. We talk at exception in future. And let's look at the basic syntax structure of C programming languages. We see the IO stream. The IO stream here we're having here is the input IO stream, input output stream. The stream comes from here. We have our terminal here, our input, and what we input here, and what is being displayed for us here. So this is our input output stream. Then we look at this, the include statement enables us to include the library, default library that came with the compiler. Understand? You can also see our main functions here. You can see the print out statement. We print hello world, stdout statement. You can read the comment to get more. Return say conventionally 0 means successfully executed. Understand? But when we go to functions, I'm going to explain to us the reason why we have what the int main are also the return 0. So also see this. So 3, we also see the processor directives. The hash was is a what preprocessor directives. So enable us to include some all the library that we need to use. Because we IO stream vector in case you want to use dynamic list. I'm going to be talking about them. If not defined, then use this. Namespace as well. stdout provide a way to organize code into logical groups and to prevent name collision that can occur especially in large projects or when using multiple libraries. Then the essence, the essentiality of that namespace will come into what? Come into show, will come into use. Understand? You can use std this, you can read all the slides, you can see the main, function here, the mandatory entry point for every executive program call. What does it mean? Let me, for example, now, let me just remove this, for example. Now, if this is the main something, right? It's telling us this is the main, our program, no matter how many classes we have, the main function is the entry point. If we add something here, maybe int 90, understand? Now, can you see, especially an identifier? For example, now, okay, int score equals to 90. We give it a score here. This is global to this function. You can easily print it out here. But if that's okay, we'll see out. Let's try something. Now, if you can see that the question asks no storage class or type specifier, it's not even taking it in, right? Then it cannot be used here. Okay, for example, if I even declare another function or a class without calling it here, just like what we saw the other time, the class, without calling it, it won't run at all. It will not run. So there's a period of a program start from here. Sometimes you can see it in some of the code outside. Don't put void here. Means it should not return anything. It will still work without this. It will still work. Can you see hello world showing here? Hello world is showing. It will still work. Can you see? With the void statement included. But sometimes also you can see, if you see this, if you check this, it says the mandatory entry point for every executed per program must be named main. Type return is int. That means the return type is saying this is the int it's talking about. This is the return type here. And this is the return value here. Return 0. That means if you got here, that means it's executed successfully without an error. Then common forms, we have int this, int argument, int character. So you can also see it in some of our C code. You can also have int this. We are passing something to our variables, car, argument value of array, right? So this you will still run without passing any value to array. It will still run, but mind you, let me scroll down. I see. Mind you, expect us to pass something in case you want to pass some data in. The first name, let's print out something. Let's compile with our normal code to be able to see. Now let's print what the first value will be. C out in argc. What is it telling us? Telling us, okay, the number of items in the number of items will pass, number of parameter will pass. That number it will tell us. So the number of items will pass. Let me come to my terminal. Let me compile it. I'm inside cd. Let me move to new cd new op. Then g++ -o for output. You compile to as output -o. Let's give it a name. Let's give it maybe p11. Let's give it a name, but the name of the file is what? p1.cc. If we compile this now, then to run it, can you see another file has generated here? p11. Can you see? It's saying what? I'm having only one argument supply. What is that argument supply? That is what? That is the name of the file. How do I know that is the name of the file being supplied? Let's print it out as well. Arg v. You know it's an array. It's symbol for array. Then the first index is the first item there. Now let's print it. Let me compile again. Can you see? It's P11. You print out what the name of that file. Now, if I print out, if I want to, maybe I now enter some other values items. Maybe, okay, now let me enter some other value item now, there now. It's going to tell me, let me enter like maybe 4 or 5 items along the way. But let me print this second index. It's going to show me what the second index is. For example, if I compile this now, good. Now let's come into show. Let's leave in, let's watch, and let's see how it's going to come into place now. Then we have for me to run it, this is the name of the file, 11. Then we have the name of the file. Let's pass something. Come, go, when, use, hover. If you run it, can you see? You put it out go, which is what? The second element. This is the first 0. This is the first 0, 1, 2. Can you see? You print out go. This go, that is the number of the elements. So now let's try. Let's continue. You can demonstrate with many things as I've illustrated. Then statement. The small statement, it can be your int a. It's one independent unit of execution in the code. Can be int s, int y, int s equal to this. You can just declare statement is a statement. Understand? We also have a functions. We also have inbuilt functions. We also have some what called user-defined functions. We user-define the functions, right? Let's see a sequence of 0 or more statements. Can you see a block of code? A block of code. Can you see now? You can have this block here with the starting point, and this is the ending point. By the time we are opening any braces, just as we are seeing here, we open the braces, a block. This is the content of this block here. So everything in this code, it can contain one and more line of code, statement code to be executed. It's an instruction to print out this. A statement can just be, you can just declare a what maybe int x, right? Just this. And initialization is x equal to what? Maybe 42. This is declaration. First slash is comments. Declaration. This is what? Initialization. Int y equals to 90 is called declaration, and with initialization. With initialization. I see. This is together. Declaration, initialization, it's like that. Then this is the block of code you can see, and you also see some rules. You can name your code, your numbers, whether you with alphabet, small letter, capital letter, just the same way. You can see user age. You can name that maybe, for example, car. To name a user age, you can use a string user age equal to what? So its age, user age should be an integer or sign. Maybe unsigned, and its name is positive, not user. It can be in this form. This camel casing is what 45. Unsigned. Then we have this maybe string. Use the first name. You can say okay, username. Just make it just sorry. Let's use that name. You can do it this way. Equals what? Frederick 2234. Understand? Then you can also say okay, string first name can be this form. First name can be in this form, maybe Isaac. String last, can I will say it this way. One point. And see, we have it this way, and it's still acceptable. So, but if you can't just be saying maybe something in string, another name, Can you see? You cannot start with this. You cannot start with something like that. But you can still start with underscore. You can start with zero number. Understand? So what should we even give you error? Can you see expect identifier? It's not seen as an identifier. That is what's being told. Give it a normal name. Well explained name. In some programming languages, signifying underscore like this means a private variables. Understand? Then remove down keywords. What are those keywords? They are words that the compiler recognize, like if, else statement. You cannot just use them in your code. For example, I want to name as name of a place. For example, I just want to do something like this. Maybe I want to name this, and I say, okay, if the name of that if is what? Is come. For example, you see some error here. You can, these are what? Especially an identifier, but you see if this kind of, these are commands used. These are keywords used by the compiler itself. But if you still want to use that if as a name, as a variable name, can simply add what? Underscore in front of it. Then it will accept that from you. But you can't just use the keyword exactly the same way it is. Also have some private of those keywords. They are keywords literal. You also have integer values here, constant variables. Also have string variables, booleans, no pointer, variable declarations. I've first explained to us item prices using camel cases as well. Thank you very much. Okay, so now I want to demonstrate for us the use of the while statement in case, if for example, we want in our code, we want the user, we demonstrated for loop the other time. Let's demonstrate for while loop. Maybe for example, until the user enter maybe a password that the length is greater than 6, you can just say, okay, maybe for example, car password, maybe string password, for example, here equal to what? Maybe this one is what? Newt 2. So this is the password here. So see out. Let's check the size of this Then we have what password. Then we can just easily run it. What do we have here? It's telling me 32. Give me that 32 bit straight. So it's giving 32 bit or 32. So and this is not up to 32 character. So for example, let's just make use of car. Let's get it. Yeah. Let's use C base. Let's use C base character value. Yes. We get 12 character here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the last one is /0, which is not included here for C character base. That makes it 12. Understand? Now, but maybe for example, if the user enter, if you use size up to check the size of the something and the size of that something, if the length, but for the other time, let's use for size. That is shrink. So now let's check this. Let's use instead of this size C of this. What is it taking? I'm coming. Size C. Okay, let's use it's trying to get integer from us. Okay, let's just use size of. Let's just use password, the size. Let's get the size of this. We get exactly 11. We're able to get 11 as the size, not the type something. Now let's try to check that. Let's allow the user to enter the password. But then the user enter the password. Let's check if the password is what? Is correct password. Is the length is more than this? If not, then it should display an error. Let's check if the password is greater than 16. Maybe the password is maybe more than 6 or 7. Maybe password is there. Maybe check password length. Then let's check the user. Use the cin operator. The cin operator, insertion operator to insert. Now you cin, but before then, let's tell the user information to enter the password. Or else if you don't tell the user to enter the password, the console will just be blinking, not knowing what to do. Now let's see out. Please enter a password. Not less than 6 characters. Now let's check now. But we are telling the user to enter it now. You see cin operator, and this is the insertion operator. This is cin, this is cin, and this is the insertion operator. You should be able to get input from the user from the keyboard. Then you now store it inside password. Let's check why password the size is less than 6. It's less than 6. The user will just keep on pumping that, okay, until the condition matches. Then just tell the user, see out. Please enter the correct password. Then we store this. We store the value again inside our password until the user enters it. Then if it's successful, then we say, okay, see out. Okay, successfully enter password length. Let's check what's the password length. Password the size. Let's check the size of what the user entered, and then we are good to go. Let's try this code one. Let's come to our terminal here. Let me compile this. Now let me run it now. Please enter a password. Maybe come. And please enter the correct password. Me. Please enter the correct password. 42 something. When that's okay. Well, okay. 47 something. Can you see? Successfully entered a correct password. Please like, share, subscribe. We'll see you in the next lecture. Have a nice time. Thank you.